2, 3 high. How are you? Are you ready to submerge into practical features of hardware hacking? Hardware, software breakthrough. We are talking not only about theoretical things, we shall physically break in. Well, we shall see. Now we are talking about SDR. Who have ever heard about SDR? Who knows? Oh, yes. Can I ask you what it is? Yes, right, you are. It's software-defined radio. When 150 years ago Popov invented radio, he used analog instruments, a coil, a condenser, oscillation contour, oscillation circuit, antenna, earthing, and radio waves were generated or received. Now, as well as any other thing, lamps were replaced by transistors, and everything is based on transistors and software now. In good society, we have to introduce each other. Let me introduce myself. I'm Ivan Blinkin. I'm expert in IT security. I have about 20 years of experience. I have 2 higher educations with all the certificates. You heard about MIT, Harvard, Stanford, Cambridge. Yes, in Stanford, I received 2 RCEs. Hack the box, you heard it. I broke into them, and I have an appropriate certificate. And finally, in about 2 months, you will see my book about hardware-defined and software-defined radio waves. Now, what are we going to talk about? The first 20 minutes will be theory. I'll tell you briefly so that you don't fall asleep, and the remaining 20 minutes will be devoted to several ways of breaking into our radio. Now, let's go on. I have a question to the audience. What is a radio wave? Who can answer the question? Right. It's an electromagnetic impulse which works at a certain frequency. According to international ITU certification, from 3 kilohertz to 3 terahertz. Quite a wide range of frequencies. The length from several millimeters to several kilometers. That's a wavelength. A wavelength of 10 kilometers. Can you imagine that? The question is, well, it's a simple question, and you can easily answer it. What are the properties of radio waves? Please be louder. Sorry? Length and frequency. Yes, length, frequency. What other physical properties? Yes, penetration, reflection, angle of reflection, and well, a radio wave can bypass the obstacles, houses, trees. It can go around them. About 5 years ago, researchers made a certain device to look through the walls using Wi-Fi radio waves, because the waves can go through certain objects. And then it can be reflected, it can go around obstacles. Sorry for some technical errors here. Yes. Now, and the third question was answers. What are the ranges, frequencies from 3 kilohertz to 3 terahertz? As you were quite right, it's an electromagnetic radiation From radio waves, you have visible waves, invisible waves, ultraviolet rays, alpha, beta, and gamma rays, X-rays, and a lot of other things. And to demonstrate it, you cannot see the wave, you cannot hear the wave, but to give you an example, you can see them on water surface. And these are also, you can see here some peculiarities of waves. Interference, we forgot about it. Interference, when one wave overlaps the other, and we can lose the signal in that way. White noise, interference. If you broadcast on the same frequency, you can suppress all the other waves on that same signal. The signal doesn't disappear, so if you are more powerful, then you will suppress all the rest on the same frequency. That is clear. Radio waves can be emitted in different ways. Talking about payloads, payload, useful signal, we have a carrier signal, analog or digital. We can have data that we transmit, which can also be analog and digital, and modulation, which is used to transmit payload on the carrier. This is AM and FM modulations. AM is amplitude modulation, FM is phase modulation. Carrier signal is the same at a certain signal, at a certain amplitude, and payload is transmitted through a certain modulation, depending on the modulation type. And the final wave can have different forms. This is amplitude modulation by amplitude on y-axis. It is added on the carrier frequency. And frequency modulation, when the frequency of the carrier is changed, but the amplitude is the same. In principle, the same channel, the same signal, the same signal on the same frequency can be transmitted in different waves, in different ways. It's up to you. Some of them are more susceptible to interference, others are less susceptible to interference. It depends on the practical situation. Frequencies, modulations, everything depends on you and on practical situation, practical conditions. Then, let's talk about wavelength. Do you think why we as hardware, software, security, why do we need wavelength?
Все правильно, да. Основной момент, для чего нам это надо, это для подбора антенны. Антенны бывают разные,
Antennas can be different, we shall tell about them, but let me tell you some more theory. How can you calculate the wavelength? Divide the speed of light, which is 300,000 kilometers per second, and divide it by frequency. So let us have a practical example. What is the wavelength for different frequencies? For example, let's take usual FM radio frequency range, about 100 megahertz. What is the length of wave? 300,000. We divide into 100 million. Why? 100 megahertz. Mega is 10 in 6 power. And the wavelength for a usual radio that we listen is plus minus 3 meters. IoT devices work at 433 to 92 megahertz. It's a universal international range, frequency range used in any part of the world for IoT devices. Same formula. We divide the speed of light on and get a little less than 70 centimeters. And the most widely spread wave is Wi-Fi 2.5 gigahertz, same formula, and we get the wavelength of 12.5 centimeters. As you were quite right, in row 2, the wavelength is needed to calculate and choose the antenna, because clean signal is needed for the right attack. We must receive the signal and transmit it if we're going to attack anything, replay attack, synthesizing attack, and so on. So in principle, you all know school time physics, the distance between peaks. The peaks is the frequency, amplitude is from higher peak to lower peak, and the frequency is the number of peaks within 1 second. Antennas are different, and as you can see, in FM 3 meters, you will never see a 3-meter long antenna. Never. That's why to receive and transmit signals at this frequency, we use so-called halfway antenna or quarter wave antenna. You can divide the wavelength by half, by quarter. In FM, half wave is 1.5 meters or 75 centimeters. Sometimes antennas are quite interesting to reduce the size. In the next slide, yes, let me show you. As you can see at Flipper 0, wavelength in IoT is 69 centimeters, and here the antenna is a spiral. Same, 69 centimeters, it's half, 30 centimeters. How can you squeeze 30 centimeters into a small thing? You make it a spiral and put it in a smaller form factor. Let's talk about practice. Let's talk about the hardware that we use for SDR. For some of you, it's well known, but nevertheless, what is basic? A nice thing developed about 10 years ago, a device which is a usual block taken out of a TV receiver. You can buy it for our purposes. Two main drawbacks. One is reduced frequency range up to 1.6 gigahertz. It cannot cover Wi-Fi and Bluetooth. Also, it cannot transmit the signal. It can only receive it. Then, well-known Flipper 0 also can receive and transmit radio signals. Honestly, I don't like it very much because of two reasons. First, because too high price and limited frequencies from 300 megahertz to 900 megahertz. Again, it covers IoT devices, a bit of GSM, and no more than that. And it's inconvenient. You need additional software. You have to work through a computer. then no, thank you.
Lime SDR.
Then Lime SDR, a very expensive thing, professional thing. The main drawback is price. It's too expensive, and sometimes it's very difficult even to buy it at any price. The main feature, you can transmit and receive signals. It can work simultaneously. It can simultaneously transmit and receive. For example, if we take Flipper Zero and HackRF, they are half duplex equipment. We either receive or transmit, either or. The latest device I'm talking about, you can do it simultaneously. It's full duplex. You can break into GSM as a result. Light SDR also can receive and transmit simultaneously. HackRF, it's here, and this is the device we're going to use for our current manipulations. HackRF was developed in 2014 by Michael Losman. He has his own company. What is good there, apart from a high price, Michael Losman made it open source, and any person, including our colleagues from Eastern Asia, can make them through Chinese market. You can buy it at no more than 10,000 rubles. It's fully legal. The main requirement in the territory of the Russian Federation is that the power of transmission should be no more than half a watt, and the distance is no more than 5 to 10 meters. For research, that is quite enough. If you want to play with the law, you can use additional amplifiers. AirSpy, also a small device for reception and transmission. This is an interesting thing from Raspberry Pi, which helps you transmit or receive at one frequency, 433 megahertz. As you can see, it's a transmitter, and that is the receiver. The great drawback is the need to buy additional hardware, what Arduino, other devices, and write your own code. And the best thing of all, plus minus, more or less, available to a rank and file person is USRP. Comparative characteristics. This is a chart where you can define the minimum and the maximum frequency to be used from 1 megahertz to 600 megahertz. Width of a channel, what is the range that you can use to analyze radio environment. When we protected networks against data leaks, we tried to find rogue access points in different departments. Well, it turns out that this device scanned radio channel, not all from 1 to 6 megahertz, but by parts. In HackRF, by 20 megahertz each. To go through the entire range, it takes 2 to 3 seconds. You can say it's all right, we can tolerate, but sometimes the signal can be transmitted within a fraction of a second. Yes, and finally, ACP device, it cannot transmit or not, I told you. Well, Aspire SDI cannot do it. All other things can transmit and receive. Now, that's interesting. How much is it? How much do you have to spend? So the entry threshold is rather high, financial. HackRF costs $300. This is the original product which is sold at Michael Scott company. Analogs copied by our colleagues can be purchased at less than $100. Next question before we go to practice is software. Which software is used? There is a lot of software, more than 30, 40, even 50 applications that work with different devices. There are some universal ones, Cubic SDR, GQRX. There are specialized for specific devices, and I'm going to show you console version, HackRF1. If you want, if you need a console, instructions, why do we hate consoles? Because well, it requires additional things, a lot of, well, although you can use it for appropriate tuning and, well, for different purposes. It's good. Now let's pass over to practice. As I told you, now we're going to break into this doorbell. So someone presses the button, open the door. But there is a radio channel. It's just one of the devices, one of the examples. The same principle is used for opening the doorways, opening your car, opening everything, opening your garage door. They work in the same way. For proof of concept, we shall use just the usual doorbell. Before breaking into the radio wave, we have to look how it works. There is a battery, a button, a generation of the carrier, the printed circuit, and transistors to amplify. Antenna exists, but on the other side, it is another. It is done on a printed circuit as such. So this is the way the transmitter looks like. Now let us break in. We have several methods to do so. Let's do the replay attack by using native software for HackRF. Then we'll do the same in GUI version, in a visualized graphical user interface, and in the end, we shall analyze the signal and well, synthesize it. Let's go to the command. Line interface CLI RF info. So HackRF is, oh, can you see it, or do I have to increase it? Is it visible? Okay. HackRF is there, serial number, date of the firmware, a bit outdated, but it works. Additional functionality is not required, so we can tolerate it. Next application, HackRF transfer. What do we do? Let me do it this way for you to see. HackRF transfer is launched. It has a lot of keys. One of them is F. F, as you can see, is frequency. Frequency in hertz. So you have to indicate everything. 4 digits after the decimal point. Next key is S. Sample rate. How many symbols are catched, are caught per second, and R tells us how to name the file where we're going to write the signal that we intercept. We have HackRF, we have an antenna, and we have a transmitter. Now, I am going to press the button. The reception software is going to work. Then I'll press the doorbell button, and this signal will be recorded. Enter, right, and close. Ideally, as far as I think, if everything's all right, because that is hardware and software, well, someone synthesizes it. Please don't do it. But the idea is good. Thank you. Please tell me what is the code. 66, we're going to decode it. Yes, later on. As you can see, the channel, the signal is recorded, and now we're going to attack. A young man already did it. It's a replay attack. We're not going to see what is the payload, what is inside, what is the code. We're going to take the signal, the recorded signal, and transmit it. So we'll leave it as it is. Yes. We'll leave it as it is. Instead of R, we're going to indicate T, transfer. Which file? It was recorded, and this is power. The power of transmission, because by default, the power is very low. Even at this small distance, the bell will not receive the signal. It will be too weak. Now we tell HackRF the maximum power. Now, if you are most active, please keep the bell. I am not going to press it, and let us transmit the signal. Are you pressing it? No. No. No magic. Everything works. In this case, we carried out a simple attack, replay attack. We received the signal, recorded it, and then we retransmitted it without thinking what is inside. Replay attack. Now the same attack, but we shall look inside the signal. Those who know the subject know about the software. It's a powerful application. I like
SDR,
it.
you've heard about this probably. Comes highly recommended, especially as the gateway into hacking radio. Can I get my prop back? We'll be recording and use signal.
So what
we have to do? The interface is very simple. We select the device. The drop-down is quite big. Hack RF, AirSpy, Lime SDR. It's all supported. Goes down to you at your choosing and the depth of your wallet. The default frequency is 433 for IoT, and the sample rate shall be the same, right? Let's set it the same, 2 megahertz. The same steps. We start recording the air. I click the bell button. I think that's enough. As you can see, we have captured the signal. Let's save it to desktop, where there we have it. You can now look at it. Let's trim it at the bookends. This software supports it. Zooming in, we can see the payload that was sent over the waves. A question to you, question to the room. Is there anything curious? That was a correct answer. I'll restate it with the mic. The signal is repeated however many times. The code is the same. You press the button, it sends the same payload. This is what makes replay attacks possible. You record it, you replay it. No extra steps required. If there was a rolling code in this device, then each time as you push the button, the payload would be generated anew. As InfoSec security experts, our next step would be to find an algorithm, the formula, which the transmitter uses to generate the frequency of the wave. And then at the other end, the receiver, taking it in, considering it legitimate, and acting on it. That's what's called rolling code. That's what you have in car alarms. Upscale radio-operated gates do the same as well. Government facilities, for example. This software is also nice because it has a decoder built in, so it gives you a numeric representation of the signal, ones and zeros. Before playback, you might want to do demodulation. The default is ASK, amplify shift key, except of the sine wave, it's ones and zeros. This app is really great because it does demodulation. Once we do demodulation, you see a very nice bit of code. Ones and zeros, the bread and butter of IT. Let's keep it up. Keep it up on the screen, because we'll need the app still. Let's redo our replay attack. You hit play. Oh, I didn't set the power called gain here. It's very close, but it didn't arrive. I'm not pushing the button. There you go. Works. Works just the same. Yeah, question. Please wait for a mic.
А может быть сигнал аналоговым, а не цифровым?
Can you send an analog signal, not a digital signal?
Аналоговый сигнал — это, для простого примера, это радио.
An analog signal is something like radio.
В данном случае, я думаю, вряд ли это возможно, потому что тогда придется производителю
like this.
привнести
I don't think it's
сильные
possible in
изменения,
this
ввести
case.
много ресурсов для того, чтобы, собственно, это
It'll
сделать.
take a lot of resources and changes to
Если мы
implement.
говорим про цифровые вещи, все-таки используется цифровой сигнал.
Digital electronics usually use digital signals. This is also analog in a sense, because instead of a sine wave, you have pulses.
Это цифровой, да.
What we're looking at is digital. Yes, it's analog signal modulated as digital pulses. So that was our explanation of how the signals look. This gets us back to the deck, where we'll be assembling a radio control device. Do you know what app this is?
GNU Radio Companion, да, все верно.
GNU Radio Companion. Yes, that's the one. Let's fire it up. Just a sec.
У меня, чтобы, опять же таки, сократить время и не сильно мучить вас большой теорией.
Not bore you too much with theory. I've reset it.
Это профессиональная схема, то есть это уже...
This is a professional representation.
И у нас есть, собственно,
that's a transmitter on steroids.
Скажем так, простая схема.
And then we have a simplified view, as was just shown in the slides.
GNU Radio это, по сути,
what does GNU Radio does? It's like a brick Lego thing, just like Scratch in programming.
Возможных блоков, которые существуют, ну, которые в данном случае...
You have boxes that can be dragged and dropped.
Соединять между собой. И после того, как вы
you can join them, then you hit play, and this code will be exported as a Python script for you to run it outside of this compiler software. You visualize it, it spits out a script.
Что у нас здесь есть? Для того,
so what do we have here? Just like LLM, not on steroids.
А для того, чтобы
to be more than a script kiddie, capture and play back, if it's a rolling code, you can devise an algorithm that will be sending different things each time. The example is quite simple, and you have a static signal.
Почему это так выглядит? Потому что мы с вами
Here is how it looks. A bit messy. But this is because we are sending ones and zeros in the same form that we've received it. 1001, 1101, and so on. This is what we were sending.
100,
1000, 111.
Понятно, сейчас компьютеры достаточно мощные, и там подправить там 100 сэмплов.
Computers are quite powerful. 100, 125 samples doesn't make any difference. But it's critical for radio. Then there is repeat interpolation.
Какой ширины должна быть эта
единица? The width of each zero, wavelength, distance between peaks. It's critical in this case because it's measured in time. How many units of time are there in ones and zeros? You multiply it by 0 because we have the button.
И, собственно, когда запустится у нас
GNU push button. When we run the code, we'll have a window with a button for us to push and modulate the signal or synthesize it. And then you feed it to HackRF sync to transmit the signal. I've preset the frequency 433 and the sample rate as well. Let's fire it up. That's a nice window that we see, not touching the button, just holding the antenna, not too far away. I hit ring, and you should hear the tune. So it's not just a replay attack, it's the same signal but synthesized from scratch. There are things a level higher, something a bit more professional. It's pretty straightforward, but you still take a picture. The vector source is represented differently here. Not thousands and hundreds of ones and zeros, but the representation is different too. Why do you think? Why do you think is that? That's a trick question. Just data. This is all data. No, this is all data. This gets us back to your question. Loop 0 intercepted the signal as 66. It was converted from its physical state to logic. So, by way of example, let's say that a short peak and a long pause is 0, and long peak and short pause is 1. We make a logic out of it. So payload would be 0, 1, 1, 0, 1, 1, so on and so forth. What you're saying offline there is different. Let's discuss it separately. We have just converted the physics into logic. We get a code output. If we were to convert it, we have some time. Just a sec. Edit, replace. Let's remove the commas. If we are to convert the code from binary into 16-bit system, you'd have something similar. We don't have 0 and 1 at the beginning and the end. It has to do with the protocol. It has to do with the protocol. It has Princeton. Yeah. Not here. Someone else. Yeah, it's just a feature of the protocol. It's now a logical representation of a physical signal. The formulae there are boring and daunting. Never mind, the conversion is done. It works much faster. Again, someone's messing with the bell. Of course, and when it has to ring, it doesn't. Well, something went wrong there, apparently, at some point. But the idea is the same. Let me go to the last slide. We've covered some ground today. Hopefully, you've learned some new things. I really hope that it was interesting for you. Please, as always, subscribe to our media. I work at Bastion, a company where I'm responsible for hardware hacking. We do similar attacks, we do firmware analysis, and many other things. Our website, that's my personal development, Telegram, and Telegram channel, our work chat at the company. That's it from me. We have 6 minutes for questions.
Подскажите, вот вы показывали приложение GNU Radio.
Could you please say a few words about GNU Radio? It's a bit more sophisticated than the other ones. Is there any documentation? How do you find your way around it? It's an open source software, also developed by Michael Osman, who developed SDRcraft. He has a number of courses on YouTube. I'm not going to give you instructions of any sort, right? Easily searchable, easy to learn. Yeah, I've omitted one point. Hardware hacking in Russia is still underrepresented because there aren't almost any Russian language publications. All research, all developments are in English. If you want to really study it, to brush up on your English if you haven't already. Do your searches in English, because in Russian the amount of information is limited, or translations can be wrong. Do use international resources. Michael Osman offers an introductory course on GNU Radio Companion. Google or Yandex.Set in your tech sovereignty. You can acquire the knowledge. Might be painful at times, you need to have some insight into physics, but then if you mastered it, you have great career prospects. Hello, Ivan. Thank you for this nice presentation. I have 2 questions. At the top of the presentation, you compare different devices. Which is the most convenient for novices if you do not factor in the price? What works out of the box? Well, you'll need some knowledge to start off. Value for price would point you towards SDR. Come on, this one. Around $40 on eBay or 5,000 rubles on AliExpress. Nice reception, very clean signal. Sometimes it's a bit dirty in SDRcraft. The range is broad, the antenna can be mismatched. You're not always too pedantic about it. LTR SDR captures very clean signals. It gives you some range. But let me underscore once again, it cannot transmit. So, to analyze some signals, along the ropes, I got cheapo RC cars, preferably 27 megahertz, not by 2.4 megahertz. Get one NRC car or a helicopter operated at 2.7 megahertz. It's around 3,000 rubles on AliExpress. Yeah, 3,000 to 4,000 will get you the whole set. Antennae, mounts, let's round it up to 5K, and you'll be all set.
Кстати, да, хороший вопрос. По-моему, оно... Сейчас, дайте, я уже не помню. У меня... Нет, 24 работает. То есть, в принципе, CB радиостанции также можно послушать. Но это...
It has 24.
Там, где дальнобойщики сидят, и просто...
CB radio can be received. That's trucker radio. You can get some GSM, but you'll not be able to listen in because it is encrypted. You can catch a satellite. You can listen air traffic control, radio, everything in this range. If you have a demodulator, then you'll be able to listen to police. Okay. The table says that this module for 33 megahertz for Arduino can transmit. So it can replicate the attack that you've shown. Yes. Transmitter, a generator, wave generator, and the receiver. They're usually sold as a pair, 200 to 300 rubles. If you already have some Arduino stuff or Raspberry Pi, hook them up. There are a lot of guides online. Then there are enthusiasts as well who assemble universal scanners with Raspberry Pis. They get onto the car and start collecting signals. They decode it, capture and store it, but it's not entirely legal or undesirable at best. Thank you. What should be your first steps in learning rolling codes? Something more complex than increments, but what are the standards or protocols? The key thing is to discern the algorithm. The easiest thing is timestamping. In Linux, for example, you can convert seconds, minutes, hours, and dates. And this string, how many seconds since 1970, you take this, add some payload, and send it. So keep track of the time and convert it into Linux timestamp as well. But the two devices should be time synced. If they're not, then there are other things. You'll have to disassemble it, dump the firmware. Alexander knows. He's been at our booths where we told all about firmware dumping. Just like I did with the log, hook up with the oscillograph or hooks, and then logics and maths are at your disposal. So you'll need to learn firmware dumping. Okay, so the most basic authentication token is timed. Yes. If they have a battery, both ends, most likely, yes. Hello, thank you for the presentation. I have a question about geolocation, which is an issue in Moscow, has been recently. You can't do anything about jammers. Well, you can convert hack RF into a jammer. No, but how can you cannot receive the signal. But what if someone spoofs it? You could filter out a stronger signal that's transmitted from Earth and then still receive the weaker signal from the satellite. Are there any pitfalls? I'm told that the time is up. Let me give you a brief question. We discussed interference. If the signal that's transmitted from Earth is more powerful than what's GPS jammers, white noise generators, then you'll receive it. If the transmitter and the jammer are in the next rooms to each other, then it's a measuring contest, basically. Okay, we are out of time. If you have any more questions, I'm available offline after 5 to 10 minutes once I've backed up, and I'll be available. The organizers have a giveaway. The best question receives a book. I wanted to give it to this young man over here. Thank you for your interesting questions and keep learning. Thank you, Ivan.